everyone, in this video I want to demonstrate how you are able to read in the answer report and the sensitivity report from the linear optimization solver report. And so if you don't know how to developing the results, please watch the previous video. So there is the two video related to here. First is learn how to, based on the business case description, to set up your the formalize your optimization problem on a piece of paper. Basically, write down your objective function and your constraint as equations. And then the second video is related to how you are moving those equations to the Excel so that you can use the solver to solve the problem. So you should already watch the video and set up your 4 tables like below, and then solving the problem, getting this to report. Like I said in this video, I will talking about the answer report, and in the next video I will talk about sensitivity report. Okay, so the first is our answer report. So on our answer report, you're always going to see 3 tables. So the first table is called objective cell, and the second table is about variable cell, and the last table is about constraint. And I'm going to walk one by one, especially to highlighting the value you need to read for answering any linear optimization problems. Okay, so for this one, we are looking at the store, try to decide how many winter jacket and the pockets need to produce. So they are facing 5 different kind of constraints. So after we're solving this profit maximization problem, as you can see here, our constraint is called, our objective is called a profit maximization. So in this first table, the last column called the final value here, and you are able to identify the value that is the highest value you can achieve for this objective function. So if you're working on the opposite problem, if it's a minimization problem, so therefore the final value will be the smallest value you can achieve for the objective function. So for this case, so this company can the highest profit they can make is $3,950. Okay, so this is the first value you can find from the objective cell. So for the second one called variable cell, remember in this case, we have 2 decision variables. One is the number of the winter jacket to produce, so the other is the number of the pocket needs to produce. So therefore, in the last column, the second column here from the right, called the final value. So this is where you can find the value for your choice variable that can maximize your objective function here or minimize your objective function. So basically, if we are producing 300 winter jacket and 100 pocket in this situation, we are able to achieve the highest profit, 3,950. So this is the optimal solution for this optimization problem. Okay, so this is the second table, variable cells, where you are able to obtain the best value for your decision variables to achieve the objective function. And then the last table is called constraint, and we will highlighting several places. The first is about the cell value. So the cell value is corresponding to initially when you set up a table here, the quantity used. So basically it's trying to answer the question, when we are achieve the highest objective function value and given my optimal choice variables value, and then what is the value for each constraint. Okay, so for the fabric, the value we achieve is the 3,800 feet. For the machine time is 650 hours, and a tailor time is 900 hours. And the number of the jackets we end up produce the 300. The number of the pocket we end up produce is 100. Okay, and then this is the first called the sales value. That is the value of its constraint achieved when you achieve the optimal solution. Okay, the second is about the static column. So the static column is looking at, are we able to achieve the equal sign of your constraint? So basically, did we meet the optimal boundaries? So basically, if you look at this case, for the fabric, the limit is 4,000 and the machine time is 650, tailor is 900. And then if you look at this sensitivity, the answer report here, and since when we achieve optimal, we only use 3,800 feet instead of 4,000, which is the highest you can use, amount you can use. So therefore, for this constraint is not binding. However, for the machine time and the tailor time, since we only have 650 hours for the machine and 900 for the tailor, that is also the constraint result after we achieved optimal. Therefore, these 2 constraints are considered as a binding. Okay, so then for the number of the jacket and the Parker, the upper limit for the jacket was 400 and the number of the Parker was 150. So therefore we did not achieve that upper limit. So therefore we call it not binding. Okay, so the data here is literally telling us, did we achieve the limit we set it up? And then the last column called the slack. So that is measure how far away from our the constraints value to the limit. Since for the first constraint, the fabric, the upper limit 4,000, we did not achieve that. So that is 200 feet away from my maximum, right? So therefore we have 200. But for the other two constraints, the machine time, tailor time, we used all the available hours we have. So therefore the slack here will be 0. And you will notice that for the constraint that are binding here, the slack time will equal the slack here value always going to be equal to 0. But for the constraint that is non-binding, so the slack time will be the limit you already have at the very beginning of this problem setup. Using that number minus the sales value, that is how you're getting your slack time. Okay, so in this video we discussed the information on the answer report. So in the next video, I'm going to talk about the result from the sensitivity report.